afternoon, everyone. It's great to be back here in Jakarta. And welcome to our session. We're going to discuss the intersection of robotics and AI and the next frontier from robotics. My name is Faiz. I will be moderating the session today. And I'm a partner at Binex. We invest in early stage companies across Southeast Asia, India, and Japan. And over the past few years, we've seen how AI evolve, from analyzing data on screens to basically interacting with the physical world. And the convergence of AI and robotics is really opening up entirely new possibilities, from smarter factories to autonomous systems to tools that make robotics more accessible to anyone. And to explore this topic further, today we're joined by two remarkable founders and speakers. We have Daniel Ong, the founder and CEO of Menlo Research, and Daryl Lim, the co-founder and CEO of Augmentus. And to begin with, maybe I'd like to ask a personal question. What initially attracted and brought you into the world of robotics? And also, please give a very brief introduction about you and the company. Thank you. Maybe we can start with Daryl.
Hey everyone, my name is Daryl, co-founder of Augmentus. So just a quick introduction. We are basically the eyes and brains for industrial robotics. I think this panel is quite interesting because Daniel comes from a very different world, but my world is I live and breathe manufacturing. So the reason why we started Augmentus is because of our personal experiences when we were in A-Star back in Singapore. Maybe some of you here don't know what's A-Star, but basically it's a government research institute. And we are very focused on, we're actually a part of a subdivision called ARTC that's focused towards manufacturing, particularly in aerospace. So we program robots like so many times. Think of the KUKA, the ABB, the FANUCs, and it was quite traumatizing. If any of you here program a robot, you would know. So we thought, why can't robots be easier to program, right? So we kind of built hardware and software to enable robots to have eyes and brains so that it can self-program in some way or shape. And we're very focused towards manufacturing. So think of welding, think of painting, think of spraying, think of polishing, sanding. That's kind of what we do. And yeah, that's a quick introduction of myself.
Thank you, Daryl. Daniel?
So I think this is a very different story. So we actually started Menlo Research in 2023 after Llama, the first model, was released. Right, and at that time, I think my wife and I actually were, with Stanford, we worked on robotics many years ago. But we realized that, with these new LLMs, like there was basically opened up a whole new frontier to what was possible, right? So, and I think we started it. But the other story is actually that we had our first son, right? So we actually started the company during paternity and maternity, playing around with Llama. And then we realized that this thing is just incredible, and there's just so many things that we can do with it, right? And I think it's actually a little bit of, I think having a kid and training an AI model and building a robot, I think is actually a very profound experience because you realize that this robot that you have in front of you is going to be the worst robot that your kid is going to see, right? And that's just going to be that the way that he's going to grow up is really around these robots and around these AI. And I think that's why we really want to build and just build this future, right? And it's just been one of the most profound experiences I think that we've gone through.
Thank you, both Daryl and Daniel. Maybe, first of all, I'd like to ask Daniel. I think we're really interested to understand how AI is really pushing the technical and physical boundaries and what it really means for the future of robotics capabilities. With the advancement of AI in recent years, how do you think AI is really changing what is possible in robotics?
So I think that's where it's just really exciting, right? Because you've worked in industrial robotics. And when did the first robotic arm come out, right? It came out in the 1960s, right? And for all of us going through robotics, we have basically learned, inverse kinematics and all that. But what has really just completely exploded in the robotic space is actually non-robotic arm form factors, non-quadruped, and almost things that we have an emotional connection with. Right? And what's really just been really, really interesting is that now with chatbots, right, you almost have this near sentient human-like robots that can do almost what humans do, right? From a companionship perspective, from an entertainment perspective, or even how we perceive other things. We don't see, when a humanoid robot walks in, there's this novelty factor and there's this interest, the way we see the robot changes, right? And that's actually completely new to the robotic space that we've just not had before, or rather was not possible, right? C3PO, all this were in film, but it was just not possible to have them in like real life world, right? And if you ask what has really changed, even when we say AI, right? There's so many different types of AI. There's computer vision, there's, next action, next joint position prediction. What has really exploded and made possible this time is actually LLM's ability to program robots on the fly and also to create almost human-like experiences when interacting with a robot, right? And I think that's where it's just been super exciting the last 2 years for AI. But that's what you're going to see is that next year, the next few years, there's just going to be such huge advances in what we see as normal in society.
Thank you, Daniel. And maybe just a follow-up question on that. I think related to how we understand the hardest technical and data challenges, and especially in bringing AI from simulation to the real world. So we'd love to understand your view on how can we possibly leverage data to make robots truly, truly intelligent?
So I think there's two parts to that question, right? There's data, there's simulations, and then there's data, right? The other part that's super interesting is basically that how many of you guys play computer games? They've gotten really, really, really realistic. Like if you play Call of Duty and all these things now, like sometimes you can't tell whether it's real life, right? So something that's really interesting in simulations is really that if they've been really good at these sort of general purpose interactions that has usually been missing from robotics, right? Usually robotic simulation is a very fixed sort of situation, but now you can actually have these almost real life digital twins where your robot can walk around in and create actually interesting data that mimics real life, right? So that stuff has been really, really interesting. And so data, simulations, that's super exciting, and all these technologies, and NVIDIA's benefiting from all of this, is all sort of converging together, where it's like almost a perfect storm to create all these things, right? But from a robotics engineering perspective, nothing has quite changed with, the gap between sim to real, where your algorithm works really, really well in simulation. You put it out here, there's this camera, this light that's shining in your face, the camera can't see it, right? So sim to real is a really big problem. But then I think what robotics engineers now do is that they do domain randomization, right? To really introduce these sort of noise and factors into the simulation data. And it's just a really, really exciting time to be able to just generate tons of data. Yeah.
Thank you, Daniel. Daryl, I think you're building something very, very interesting, and I think Augmentus is really trying to transform industrial automation. And maybe related to actually my first question about how AI is really changing what's possible in robotics. But there is always this question mark whether the scaling laws is applicable. And when I mention scaling laws, I describe as how a robot's performance changes as you increase resources like training data, etc. So how does scaling laws, do you think, will apply to the physical world?
No, I think this is an interesting question because the truth is that in the physical world and especially in manufacturing, which is where I live, we're not seeing the robotics products or implementation scale like how SaaS has scaled, right? So it's a very, very different approach. But the way in which robotics in general can scale is really by doubling down on the data set. So I think it's very similar to what Daniel was sharing about. I think he was basically giving a definition of what synthetic data is, but I think it's a very good way to describe it. But that's actually what we're seeing across the board. And if you look at the past, I would say 10 to 15 years, AI is in general as a concept, it's not very, very new, right? You have OCR, you have NLP, and in fact, synthetic data was around for 5 years already, right? It's just that this convergence is happening over the past 1 or 2 years. So we're seeing this use of data to make robots more adaptable, and you can use the word intelligence, but intelligence is a very broad concept. So I like to boil things down to intelligence being implemented in 2 key areas. One is making it very easy for a non-technical operator to operate a robot, to use a robot, right? You don't have to code because the system codes for you in a sense. And the second one is to make it more adaptable. So if the part changes, if there's deviation in the process, there is going to be, the robot's able to account for that. And I think many of us here, when we think of manufacturing, we think of automation, right? We think that machines are doing a lot of the work that's being done, and that is true for repetitive processes. But if you look at the data, less than 20% of manufacturers own any form of robotics. So you're seeing a huge, huge untapped market. And the reason why manufacturers don't use robots today, even though it's the most applicable high-value avenue for robotics to be implemented, is because of this concept called variability. Every part is a bit different. Every process is a bit different. We don't live in a world where every single thing that we create is exactly the same. And that's where AI comes in and data set. It makes a robot more adaptable for the process, and that is the only way in which it can scale. Yeah.
Thank you. And a little bit follow up from that question. I think there's still a lot of big bottlenecks, especially in connecting AI to the physical world. And as of today, what do you think makes connecting AI to the physical world is very difficult?
So I can only speak from my experience, which is in manufacturing and industrial automation. And this is, I think, it's difficult because AI, by its nature, is relatively undeterministic. So what we mean by this is you put in two inputs, the same inputs, you can get two different outputs. Because right now, in terms of AI, it's quite reasoning-based, which is the way it's supposed to be, right? And you can try to lock down certain parameters and certain in the tech stack to make it more deterministic. So for example, you don't use AI to generate the motion and plan the motion directly through AI. You can use the OEM's motion planner directly as well. And there's a lot of ways to go about it. But in my world, we need to be very, very deterministic because everything is what we call mission critical. When you manufacture an iPhone, when you manufacture a car, an aeroplane, if the robotic system scans the same thing 2 times and gives you 2 different outputs, that is a very, very big red flag, right? That's the world I live in, which is mission critical. And so while AI has a lot of potential, you can't implement it in the shop floor right now because of this huge gap in deterministic behavior. I think there's a lot of work being done right now in terms of locking certain things in the tech stack to make it more deterministic, but we're still a while away. I do think where AI, in terms of an end-to-end AI pipeline can work, is maybe a bit more towards I call it the low precision, low complexity application. So you're seeing a lot of humanoid robots today, folding clothes, folding laundries, pick and placing things. That is what I call low mission critical things. A lack of precision doesn't affect much. So you see those being implemented right now. But in the world that I live in, which is manufacturing and industrial automation, there is a big gap, and we don't really have a clear solution right now. I think Augmentus has a path to get there, of course, but we are still very, very early in this journey.
Thank you. Maybe coming back to Daniel, I think a lot of us here would love to understand more about the emerging opportunities in this segment, especially around new market sectors which will be most likely transformed by the advancement of AI and robotics. So where do you see the biggest white space today at the intersection of AI and robotics?
So I think our philosophy at Menlo Research is really that AI is a tool, right? Like robotics is significantly bigger than AI, and AI is really just a tool. And even within AI, there's a lot of different types of AI, right? There's computer vision, there's speech, there's audio, there's LLMs, which now exhibit reasoning abilities, right? I think what's very, very, and these are, even LLMs today are what I consider, very, very, I wouldn't say the word commoditized, but like they are what they are, right? I think something that's very, very, very interesting is actually these adaptive algorithms that are able to take tactile feedback, right? Or if you have a vision sensor and you have, and it's using all these little tools that we have had in AI to create almost a world representation, right? Look, now all of you have your eyes open. You're hearing my voice, right? You are hearing and you can tell which direction the voice comes from. And if you've driven in a Tesla, you see that they have a very reduced image view of the world, right? I think something that's very, very interesting that's traditionally blocked generalized robotics is really an understanding of space, of physical intelligence, right? And so that's number one, right? Can we actually encode the world, right? So that's number one, encoding the world. The thing that allowed LLMs to really take over was that they figured out how to encode text, right, using transformers. Is there something similar for robotics in physical space? The second thing that's very, very, very interesting is that I think, and maybe this is a bit controversial, is that I think most of the approaches right now are really taking the wrong lessons from the wrong wars, right? Scaling laws, that's for LLMs, right? Robotics, your biggest problem is about sensors, right? And why aren't we, as an industry, talking about sensors, right? Why aren't we co-designing these algorithms with sensors, right? And if you see the way that we think as humans, if I want to pick up something, the last 2 centimeters of precision is really based on my tactile feedback, not my eyes, right? But right now, all of my algorithms are all based on vision, not tactile. And why is it all based on joint space rather than force torque, right? And so white space, there's entire blue ocean there, right? And I'm not sure whether we are learning the wrong lessons from the wrong wars.
Interesting, Daryl. Thank you. Daryl, I know you're in the Augmentus is in the industrial space and focus on transform that. But based on your experience and based on the years that you have spent in the space, and given the development of AI and robotics today, which industries do you think will be transformed first, and maybe which one will be transformed last?
Yeah, so the use of AI, I think as I mentioned before, in the industrial space is not new. It's been used for many, many years. I would say that, I mean, I'm biased because I think manufacturing is where a lot of the value creation happens from a, in terms of problem statement and a solution perspective, right? So I'm definitely biased, right? So I think manufacturing, I'm sure Daniel has a very different opinion, but I think manufacturing will be the first frontier. And in like most things, B2B is where the technology gets adopted and then it flows down to B2C. I think there's some companies out there, general purpose, trying to do the B2C approach and then go down to B2B. I mean, I think there's many different ways to skin a cat. But at the end of the day, my philosophy at Augmentus is the value lies in the niches. If you try to solve a problem for everyone, you're solving a problem for no one, right? I think that's a general rule of thumb for building a business, solving a problem. So finding that niche, building a product or solution dedicated for that niche first, while having the tech stack to be adaptable for different applications is the way to go. And I think manufacturing is the first case. So an example I can share with you, I think cobots is a very good example for in the world of manufacturing where, they make it so easy to use. So cobots, basically you can drag the robot to teach the robot and program the robot. So it's no code per se. And you see a widespread adoption of it for machine tending, so pick and place applications. And you're also seeing AI right now, end-to-end, being used for that, be it from a humanoid perspective or from an industrial or cobot perspective as well. So I think that will be the first frontier because picking actually, while it may seem like a red ocean where there's so many competitors, there's actually a lot of niche problems within that needs to be resolved. And AI can solve that problems. And then you dive deeper into the more complex and the more precise applications like welding, like grinding, like, deburring and so on. So then that will be the next frontier. But that's my perspective on AI in real world application. Yeah.
Thank you. Maybe a follow-up question on that, Daryl. So I think given that you're building a robotics company, and I think you've had a fair share of building it for the last 5 years, I assume. And I know you're not an investor, but what makes a robotics startup investable and defensible, do you think?
Yeah, I think it's really for two things, right? One thing is building robotics, hardware, software is not easy. And that's why you don't see that many companies being founded in this space. And the intersection between AI and hardware is not trivial. I mean, I think Daniel raised a good point about tactile feedback. That's actually fundamental in, let's say, polishing or grinding as well. You need to incorporate that in everything you do. I think in the world of general purpose is a different beast, but for our space, that's equally true as well. So that combination of hardware and software, and if you think about it, the talent required for that is vastly different from building a SaaS company. So you need perception, so vision. You need AI. You need robotics. And you need general purpose software to tie it all together as well. And all these different domains are actually startups in of itself. So firstly, the cost of building because of talent, and the cost of building because of the difficulty makes it defensible and makes it valuable. That's number one. But I do think at this stage of AI and robotics, the team is fundamental in making the company investable. If the team, for all in purposes, a bunch of fresh grads with business degrees, there's just no way it's just difficult, right? There's just no way. You can't learn on the job. You need a lot of domain expertise to build the space that we're at right now. If you're just using the application layer of an OpenAI, for example, or Anthropic, I think that's a lot easier, but we're talking about hardware and deep tech. And even if you're leveraging on OpenAI's APIs, for example, it's not going to be so trivial, and you're not going to commercialize. I always have this statement that, an MVP, to get you to 80% functionality, maybe can take you like 4 months, but to get to an actual product that's commercial, that's 99 or 100%, that can take you 2 years. So that last 20, 30% to get things stable and commercial, that is a killer. So I think thinking about that in mind, the team is fundamental, especially in the space that we're at right now.
Thank you, Daryl. Daniel, related to that, do you think will the future favor more universal robots or specialized systems?
I think in the short term, specialized systems will always win, right? And this has been known for a very long time, right? So if you're asking which industry will be transformed first, I would say, like Daryl, you're probably going to make a lot more money, right? That said, I think if you think about the history of computation, which is slightly different, right? You had your mainframes, right? And in the early days of a technology, it's always easier to specialize, right? But it's also important to look at human evolution, right? When specialized, I think it's a physical intelligence paper. Specialization is for insects, right? And I was like, oh, wow, you are writing a big check here. I think in the long run, and this is perhaps coming from a position that is more driven from the AI space than the robotic space, right? And AI being like largest software space. What we are seeing is that, look, in 2012, as a robotics student, as at Stanford, you wouldn't have dreamed of ChatGPT, right? Like this was not supposed to happen for at least 20 to 30 years, right? Every single chatbot became like, hallucinating within 10 sentences. This wasn't supposed to happen. In 15 years, we now have a ChatGPT that can talk to you almost like a human, right? I think sometimes you have to take a little bit of that faith, because I think it is entirely possible that within our lifetime it happens, right? And it does feel that the world is accelerating towards that. The only thing that is limiting us is really a data set. Yeah.
Thank you. I'm a bit curious to understand about your views when it comes to US and China. I think it's, in the backstage, we briefly discussed about Figure as well as Unitree. I think both countries are spending a lot, and both have probably the greatest talents on earth when it comes to AI and robotics. I just want to understand your view on how the dynamics between the two countries will play out, and what kind of role do you think they will play further down the road? And anybody?
Yeah, I guess I can give a short one. So actually, Daniel and I, our experience converges a bit, because we have a lot of experience in the US actually. So, and at Augmentus, we do have some Chinese engagements as well. So it's quite interesting because in the world of AI and robotics, defense applications are where a lot of money is at. I assume Menlo has some, I don't know, maybe you can share. But at least for Augmentus side, we have quite a bit of engagements on defense because this is where the money is at. And that's where it gets very, very tricky because when robotics is used in defense, you cut off from any other competing region. So for example, if you have defense projects in the US, you can't entertain any Chinese engagement. And I think that's what you're going to see for a lot of companies building these kind of deep technologies is it's an either or equation, especially when you're engaging on a deeper level in these nations. So I do think there will be a walled garden, especially in this space, because there's so much IP and it's so scalable in the physical world that every nation treats it as a kind of a government kind of protection as well. Of course, at the NVIDIAs of the world is where the first layer has to stop, but this will be the second layer for the application side. This is at least from my experience so far. Yeah.
Thank you. Daniel, do you have any view?
I think what's great about this panel is that we're like very, very different. And I think this is what is cooler is actually that I feel robotics is now big enough to have like a lot of very different views, right? 15 years ago, we'd both be talking about like we're the same constraints, you know. And maybe I'll position a very different question, right? And I'd like to say something that perhaps is gonna like tank my company's reputation and valuation or whatever. I funded it, I don't care, right? Menlo doesn't do defense robots. We don't do war robots. We don't do any of those things. Period, full stop, right? Why? It's because like, when I grew up, when I wanted to build robots, I didn't dream of like Terminators, you know? I didn't dream of factory lines. I dreamed of like a cute little furry robot that I could bring into class. And like, there's a fun part of robots that is about curiosity, that is about fun that I feel has disappeared the older we grew. And I kind of feel that now this AI, you know, I want to be specific, LLM space has really opened up a new thing, right? Is there something actually about increasing the overall TAM of robotics? Why don't I have a little trash can that can like do R2D2 noises? And can we think about it really differently in a way that expands the overall market, right? And you saw this really cute Casio robot. It doesn't do anything. Like if you show it, it just moves its eyes and it purrs. It's furry, it's like this, about this size. It looks like a cat and you pet it and it purrs, right? That's kind of cool. It's still a robot, you know? And is there a different way to look at it, right? And once you look at it that way, you stop really worrying about US and China. And you know, not every robot needs to look like Terminator, right? And what I feel is that it's really about the fun robots, right? Are there fun robots? Right, and maybe it is about like increasing the overall TAM of robotics, right? And maybe that's the other part. Like maybe it's like B2C, and then you know the improvements help the B2B. And I think it's not either or. We are all probably going to succeed. Yeah.
Thank you, Daniel. And maybe I'm also curious to hear about our region, right? I think Southeast Asia is diverse enough, and probably every market or every country has its own dynamics and advantages. Maybe Singapore is really leading when it comes to R&D and development, but we have big manufacturing markets like Vietnam, maybe Thailand, and so on. So in your view, I don't know, if you are the decision makers in Southeast Asia, for example, how can we find our niche and basically have our own leadership when it comes to this topic, when it comes to robotics and AI?
So I'll comment it again from the manufacturing side. I think it's actually quite difficult, I would say, for Southeast Asia to really be a strong leader in this space. But there is a lot of hope. So the reason why it's difficult is because from an automation perspective, the economics sometimes doesn't make a lot of sense in Southeast Asia. Labor cost is a bit low. You know, there's a lot of uphill battles in terms of automating in this region. But the hope, the key hope here is that there is a lot of manufacturing actually coming to Southeast Asia. I think you've heard of the rise of Vietnam, the rise of even Indonesia as well, right? I think you've all heard about it. Thailand, there's a lot of manufacturing coming in here. So what this means is that there's a lot of investment coming in, and it means that as a customer base, Southeast Asia is becoming a powerhouse in of itself. And when Southeast Asia can stand alone as a customer in terms of buying its own products, then that's where a lot of the research funding can come in to boost the frontier of robotics, the frontier of AI as well. I do think we are a while away from really becoming a leader in be it LLM or be it robotics, but the trend is there. It's just that I think we all have to unite together because as an economic bloc, we are very, very powerful and even in comparison with the US and so on as well. So that's the only way we can fight is by having unity and being together. But if you're isolated, it can be very, very difficult because of the labor wages and the uphill battles that we face as a customer segment in of itself.
Daryl, do you have any view?
I think Southeast Asia has the advantage of being like a very industrial base, right? Like so, and I don't think Singapore's R&D, like there's a really good robotics department in Itebe, right? And Wang Papa Habis called UPH, sorry, Pelita Harapan. There's a lot of very good talent out there, and I think, it's out of Bangkok, and there's Rawon and all that, especially where the car factories are. There's a lot of talent, right? I think one thing that I want to talk about that is maybe will shift the way that we think about robotics is that I think that there's a very, very important thing, and for the space that we work in, which is humanoids, right? There's actually something very interesting about humanoids, which is that it should theoretically be easier for a human to control a humanoid, right? Because we have the same dimensions, we're actually humanoids and all that. Is there actually something very interesting about human-robot interface that lends itself towards teleoperation, right? And this is already happening, right? Like there are robots in Japan that are teleoperated from Manila, from Makati, right? And what I'm going to predict is that for every autonomous robot system, there's always an operator override. For every drone system, there's always a skilled operator operating it. Now with Starlink, you can get 0.3 millisecond latency from Japan, Manila, Singapore, Jakarta, Singapore, Manila. You're starting to get to the point where next year, I don't think I'm going to come here. I'm going to be sitting in Singapore. I'm going to walk my humanoid here, sit down for an interview with you guys, and then I will sleeve out of my robot and go pick up my kid in Singapore, and the robot's going to attend this conference. It's going to happen. Like, from the technology perspective, all these things are going to happen, right? And it's the equivalent of the scale AI nowadays actually a teleoperator override, right? And that's actually something that's very, very, very interesting for our region.
Thank you. I think we have some questions from the audience. Maybe we can have up to 2 questions, I guess. There's a very interesting question. What are your thoughts on the current news about AI bubble?
So I can just give a quick one. I think the truth is that the opportunity and the market opportunity and the untapped market opportunity is way, way, way larger than the risk of making the wrong bets and the wrong development of kind of approaches. So that's why we're seeing so much investment into AI right now, because the scalability of AI, completely dwarfs that of any other technology that we're seeing so far, because it mimics that of a human in most cases. So there's no doubt about it. I do think there is some bubble. There's no doubt about that. But the opportunity is massive, right? Relative to the risk. So we definitely need to find that kind of use case to really scale. Be it, I think for us, the world of robotics, when that use case for AI robotics becomes so rampant and scaled, be it 100,000 robots or 200,000 robots, that completely would dwarf any of the bubbles speaking that's going to happen. There is going to be companies that die. There's no doubt about that. But I think for us as a company and as users, as builders, we should be very focused on finding that use case rather than being too concerned of the AI or of the AI bubble per se. Yeah.
Do you have any view?
I think it's the Warren Buffett quote or something, right? Every day the market gives you a price, but fundamentally, the linear algebra remains the same. So I think we didn't raise funding, and we're just really focused on the engineering. Yeah, and I think that's, once you look at the engineering, you know that what's possible.
Maybe just one last question from my end. When it comes to your work, what is the one thing that you believe, what is a big breakthrough that you think and you have, let's say, 95% confidence will happen, and that will really change the trajectory of your company? Let's say in the next 10 years.
You mean in terms of from a macro perspective, or?
Macro or technology perspective?
So yeah, I can start first. So for us, because we are commercial in terms of deployments, I would say the one thing that's the most important across the entire landscape is the willingness for data collection in the manufacturing sector. I think one thing about manufacturing that is maybe a bit unique to this space is because there's so much confidentiality and restrictions that oftentimes you can't even collect data. You can't even have any cloud access inside the manufacturing floor. So what this is actually is impeding a lot of the collection of data sets to then train models and train systems to make the system better for their application. So it's a bit like fighting a battle that you're trying to win, and you're trying to help the customer win as well. I would say this is actually fundamental, but I can see why this is happening. Think of aerospace, think of defense. There's no way they would allow such data to be collected, especially by a third party. But I think if the general broad landscape of manufacturing, if there's more policies, SOPs, or MES systems can be, being AI first or LRM first approach, that will be a massive disruption to the market and also to Augmentus as well. The product side the technology side will improve drastically. Yeah.
Daniel, you have any?
I'm going to just try to be a bit more provocative, because I think on the tech side, there's all these advancements, we can go about tactile and all that. I think furry robots are going to be a thing, right? Cute furry robots that are toys first, and then robots second. Right, and I think that it's really about the human acceptance of robots that is more important than whatever we do on the technology front, right? It's really about human acceptance and human willingness to pay.
Thank you. I think that concludes our session today. I think I really enjoy our discussion. I think it was a very enriching and exciting, fun conversations. Thank you very much, and thank you everyone for listening.